Hello everyone, myself is Dr. Pinkesh Suttaria, working as an assistant professor at Department of Chemistry, Bhavans College, Dakur. So today we have started a new lecture series that is pericyclic reactions. We have already completed one lecture that is a basic introduction of pericyclic reactions. So now in today's lecture, we will focus on the cycloaddition reaction. Okay, now what do you mean by the cycloaddition reaction? The cycloaddition reaction, when we are having a double bond, the double bond will be broken down here, a new bond will be formed by the addition reaction that is known as cycloaddition reaction. In cycloaddition reaction, generally we are focusing on the two reaction, that is 2 plus 2 cycloaddition reaction and 4 plus 2 cycloaddition reaction. So what is 2 plus 2? So if you are having ethene molecule, this is having a 2 pi electron, okay, this is also having a 2 pi electron. When this pi bond is broken down by the help of thermal or photochemical condition, you will have a cyclobutane, okay, by the formation of two sigma bond, that is sigma 1 and sigma 2. Now this type of reactions is known as cycloaddition reaction. This is a 2 plus 2 cycloaddition reaction. Now when we are say that there is a 4 plus 2 cycloaddition reaction, that is 4 pi electron and this is a 2 pi electron. Okay, now this will make a bond over here, this will migrate over here, this will make a new sigma bond over here via thermal or photochemical condition. So you can form as a cyclohexene. So here we are also having sigma 1 and sigma 2. Now this is known as 4 plus 2 cycloaddition reaction. Now how this cycloaddition reaction is formed? What is the mechanism of this cycloaddition reaction? So there are two types of modes in cycloaddition reaction. One that is known as suprafacial shift, okay, that is suprafacial shift, and second one that is known as intrafacial shift. Okay, second one that is known as intrafacial shift, first one that is suprafacial shift. Now what is suprafacial shift? Now the addition reaction can be carried out by the same phase that is known as suprafacial shift. Okay, so the orbital overlap from the same phase, that is orbital overlap from the same phase, that is known as suprafacial shift. Now if we are having this phase as a reverse like this one, okay, so that is known as intrafacial shift. Now in which we are having orbital overlap from the opposite phase, okay, this is from the opposite end. So that is the difference between the suprafacial shift and intrafacial shift. Okay, suprafacial shift orbital overlap from the same phase and intrafacial shift orbital overlap from the opposite phase. So this is how we can write down what is the suprafacial shift and intrafacial shift. In examination, in short question answer, they will ask this type of questions. Let's say from the question answer, first of all, let's say they will ask ethylene, in bracket they can write S. S means suprafacial, okay, plus cis 2 butene. Okay, now this cis 2 butene is also in a suprafacial shift. So how we can go from this reaction? Suppose they will ask this type of question, so you have to write down first of all ethylene molecule like this way. Okay, now this is CH2 ethylene, that means CH2 double bond CH2. So we can write down by the orbital minus plus. Okay, both are having a similar direction because of the suprafacial shift. You can also write down hydrogen downward side, okay, below the plane, this is the above the plane, this hydrogen below the plane, this will be above the plane. Okay, they have also asked cis butene. So what we have to write down, the similar type of p orbital we can write down over here. We can write down minus plus. Why minus plus? Because there is a suprafacial shift. So here I can write down cis butene. So both the CH3 group, okay, here we are having a CH3 group, okay, both are in a similar plane. If we write down below the plane, so both the CH3 below the plane. If we write down above the plane, both will be above the plane. So now what will happen? This will interact with this one. So I have to write down one more step for the better understanding of suprafacial shift. So that is minus plus over here, minus plus over here. So I have to write down this orbital from here. Okay, when I write down this orbital from here, so what I have to write down, the interaction or bonding will be the similar phase. So I have to write down this way by the plus minus. Okay, I have to rotate. I have to rotate this orbital. So plus minus will be in a similar direction. So at that time, this hydrogen will be upper side, this hydrogen will be below the plane, and above the plane. Whatever the geometry will be there, it will remain as it is. Here also what we are having, CH3 above side, CH3 above side, this will be the below the plane, this will be the below the plane. So what is the product now? The product will be like this. So here we are getting a cyclobutane. Okay, in this cyclobutane, what will happen? This part will remain as it is. Okay, all the hydrogen will remain as it is. Whatever the hydrogen atom is there, okay, that will remain as it is. Okay, so now this CH3 group, hydrogen, this CH3 and hydrogen. Now here you can look over here that this CH3 is above the plane, both the CH3 is above the plane, so we can write down this one, that is the cis-2-butene as well as ethylene molecule. Okay, both whatever the geometry in the reactant, that will reflect in a product. Okay, so what is the name of this product? So the name of this product is cis dimethyl, that is cis dimethyl cyclobutane, cis dimethyl cyclobutane. So this is our product. Okay, now let us understand one more example like this way. Suppose ethylene in a suprafacial shift and cis-2-butene, that is in an intrafacial shift. So what will happen over here? So I have to write down, that is minus plus, minus plus, that is hydrogen as it is, hydrogen as it is, hydrogen and hydrogen. I can directly write down the cis-2-butene in intrafacial shift. So minus plus, so I have to write down over here plus minus. So CH3 group. Okay, what I have to convert, that is first of all I have to write down this way, that is minus plus. Okay, minus plus. So that is hydrogen here, that is CH3 over here, that is hydrogen over here, that is CH3 over here. Okay, now if I want to change, if I want to interact this one to this one, so what I have to rotate? I have to rotate this orbital. So if I rotate this orbital, what will happen over here? So CH3 group or CH3 arrangement will be different. Okay, that is the first case. Okay, second one, if I want to rotate this thing, so in the earlier stage I have to write down this as a intrafacial shift like this way, and then after hydrogen CH3, that is hydrogen and CH3. Okay, suppose if you do not want to write down this way, you can directly go for this. Then after, what you have to do, you have understood that plus and plus will interact, minus and minus interact, but plus and minus will not interact. So you have to rotate one of the orbital. Like say you are rotating this orbital, so what will happen over here? This CH3 will go upside and hydrogen will go downward side. So at the end of this, what you are getting? You are getting like this way, plus minus plus minus. Here we are having hydrogen, here we are having CH3, here we are having CH3, here we are having hydrogen. Okay, so now look at this geometry. This cis geometry will become a trans geometry. Okay, so in the end, what will be your product? So in the end, what is your product? The product will be like this. Okay, cyclobutane, the hydrogen of the above side will remain as it is. like in the similar case, earlier case, so it will remain as it is. But in the below side of the CH2 group, what will happen? One of the hydrogen will be top side, CH3 downward side, here CH3 top one side and hydrogen downward side. Here you can look both the CH3 on opposite direction, so the product will be, that will be trans 1,2 dimethyl cyclobutane. Okay, what is the product? Trans 1,2 dimethyl cyclobutane. Okay, by that way you can calculate the n numbers of calculation of the cis to butene or trans to butene. In examination they will also ask like this way, that ethylene. Okay, now ethylene in intrafacial shift, now cis to butene in a suprafacial shift. Fourth one, that is ethylene in intrafacial shift, cis to butene will be intrafacial shift. So what will be the product? That you have to calculate by your own. Okay, I will give you the answer directly. The ethylene S or ethylene A and cis to butene will combine together and they will form like this: hydrogen hydrogen top and side, hydrogen, both are in similar direction. Here the CH3, okay, that CH3, both are in a cis position. So you can write down cis product, cis dimethyl cyclobutane. Okay, now when we are combined to the ethylene and cis to butene in intrafacial shift, what will be the product? The product will be similar like this one. You will get cis dimethyl cyclobutane. You can calculate this one by your own. Okay, so here I am getting hydrogen, that is CH3 over here, hydrogen and CH3 over here, that is cis dimethyl cyclobutane. Okay, so this is your example how you can go for this thing. And uh, one more homework you can find out, that when we are having two molecules of cis to butene, what will be the product? That is SS, second SA, third thing you can write down AS, and fourth one, that is AA. Okay, for the two molecules of cis to butene. They will also ask two molecules of trans butene. You can go the n number of question by using this principle. You just have to remember one thing, that whatever the geometry of reactant, it will remain or it will reflect as it is in a product. But when we are having a intrafacial shift, you have to rotate, loop by the interaction of minus plus with plus minus. Okay, the addition reaction will follow this pathway. Whatever the group that are attached over here, that doesn't matter, but the addition reaction will follow this pathway. You have to convert your structure in that way. Then after you will see the geometry whether it will become a cis or trans. Then after you have to write down the answer. Okay, so that is your first cycloaddition reaction, in which we have seen that cycloaddition reaction, suprafacial and intrafacial shift. Then after the addition reaction, ethylene and cis to butene. Then after cis to butene. Okay. Okay, now the next question is the correlation diagram. This is the most important question as far as the exam point of view. Correlation diagram. Okay, now in the correlation diagram, what you have to remember, in correlation diagram they will ask that write down the correlation diagram for the 2+2 cycloaddition reaction and shows that whether this reaction is thermally allowed or photochemically forbidden, or they will ask photochemically allowed and thermally forbidden. Now let us understand this correlation diagram for the 2+2 cycloaddition reaction, or they can ask ethylene plus ethylene molecule or two ethylene molecule. Okay, so now ethylene molecule, that is a simple, that is 2 pi electron, this is a 2 pi electron, both combined together they will form cyclobutane via thermal or photochemical condition. So this is our main reaction of cycloaddition reaction for 2 plus 2 cycloaddition reaction. Now if I want to calculate the nodes for this, here we are having total nodes, okay, that is n minus 1, total electron that is 4 pi electron, so 4 minus 1 that is 3. Here we are having 4 pi electrons, so we can say psi 1, psi 2, psi 3 and psi 4. Psi 1 and psi 2 will remain at the BMO and psi 3 and psi 4 will remain at the ABMO. You just have to write down by this way, BMO, ABMO, nodes, 2 pi electron and all that thing. Then after, the most important thing comes, how we can arrange the 4 important terminology, that is suprafacial shift, second suprafacial intrafacial shift, intrafacial suprafacial shift and intrafacial shift. Now let us understand by its suprafacial and intrafacial shift by using a correlation diagram. Okay, so now in correlation diagram you have to write down first of all suprafacial as suprafacial shift. So suprafacial shift, how will they interact? So this is the suprafacial P loop, okay. Then after you have to write down one more loop, how will they interact? Now suprafacial shift, the first word of this letter SS, you have to see this letter in a vertical line, that is in vertical line, okay. Now second word you have to see by horizontal, that you have to remember, okay. This will come under horizontal, this will come under the vertical line. What it says that in vertical line you are having a symmetric property and in horizontal you are also having a symmetric property. Both the signs are different, both the signs are similar. Suppose if I start with the minus plus, okay, here we are having vertical S, so I have to put minus plus over here. Similar case, horizontal, both the sign are similar, so I have to write down plus plus, then after minus minus. So this is the first case of suprafacial shift. Now second one, if you are having a suprafacial intrafacial shift, what it means? The suprafacial shift S, that suggests that vertical line are similar but horizontal line are different. So how we can arrange, that is minus plus over here, vertical line, minus plus, okay. Now horizontal, both the signs are different, plus, so here we can put over minus minus, that is plus plus, okay. Third one, so here we are having AS, ખબર પડે છે. ફોર એક્ઝામ્પલ તમારે અહીંયા માઇનસ પ્લસ હોય તો આ વર્ટિકલ લાઇન છે એટલે ઊભી લાઇન તમારે જોવાની છે, હોરિઝોન્ટલ લાઇન એટલે આડી લાઇન જોવાની છે. એટલે આડી લાઇન તમે જોશો એટલે તમને ખબર પડી જશે કે ભાઈ અહીંયા આગળ તમારી પાસે માઇનસ માઇનસની સાઇન છે, પ્લસ પ્લસની સાઇન છે, પ્લસ પ્લસની માઇનસ માઇનસની સાઇન છે. વર્ટિકલની અંદર સિમિલર છે, હોરિઝોન્ટલ પણ સિમિલર છે. અહીંયા તમે જોવા જાઓ તો વર્ટિકલ અને હોરિઝોન્ટલ, વર્ટિકલમાં તમે જોવા જાઓ બધું સિમિલર છે, હોરિઝોન્ટલમાં ડિફર થઈ ગયું. So that is the main difference between the suprafacial and suprafacial intrafacial shift. Now let us start with the minus plus, okay. So here I can put over here first, that is the minus plus. We can start from the minus plus only, okay. So minus plus, the vertical they are differ, so here I can put plus minus over here, okay. Horizontal they are similar, so plus, so I can put over here plus, minus I can put over here minus. So you have to change this sign. So you can see that vertical they are different but horizontal they are same. So this is known as intrafacial suprafacial shift. Now intrafacial shift, okay. So minus plus intrafacial, so I have to change plus minus because vertical and horizontal both are different. So plus minus minus plus, so I have to write down plus minus. So these are the 4 types of addition reaction, how we can go for the suprafacial, intrafacial, suprafacial and intrafacial shift. Now this suprafacial shift, that is a sigma 1 and sigma 2, this will be for the sigma 2 star, okay, and this will be for the sigma 1 star, okay. So that is the difference between the sigma 1 and sigma 2, how we can go for the correlation diagram. Now after knowing this thing, you just have to write down the correlation diagram. Now how we can go for the correlation diagram? So correlation diagram, you have to write down this line, then after the energy diagram, then after the wave function, that is psi 1, psi 2, psi 3 and psi 4. Okay, so by that way this will be your BMO and this will be your ABMO. Now BMO part, that is a sigma 1, sigma 2, that will be sigma 2 star, and this will be your sigma 1 star. Okay, so now in which we have to write down SS, SA, AS and AA. Okay, so how we can go for here? Okay, so I just have to copy this thing to here. So directly you can go for, you can write down from here. Okay, so now this is the SS, SA, AS and AA. Now then after what we have to see? We have to see that if the similar type of sign is there, a similar type of phase is there, the energy will be decreases. If both the signs are different or one of the sign is different, the energy will be increases. If the sign is decreasing, what will happen? It will undergo the downward side. The whatever the energy is there or whatever the place is there, it will go to the downward side. If the energy is increasing, it will go to the upper side. So now let us understand by its mechanism. Suppose if you are having S, both are having a similar energy, it will come under sigma 1. So what I have to write down? That will be sigma 1 under the sigma 1 under, that means it will come under the sigma 1. Okay, so the energy will be decreasing because of the both the signs are similar. So here I am not attaching this P loop. Look at over here, I am not attaching this P loop, but in the product I have to attach. So what I have to write down by that way? Okay, so this will be your sign, that is minus plus, minus plus, plus minus and plus minus. So that will be your sigma 1. Here plus minus, both the energy or both the signs are different. So what I have to see, it will come under the sigma 2, it will travel to its excited state and it will come under the sigma 2 star. So what I have to write down? I have to just copy this thing over here. So I am writing down over here, that is plus minus and plus minus, that is minus plus. Okay, that will be minus plus here, that is minus, minus and plus plus. Okay, so that is our second loop. Now for the AS, plus plus minus minus, both the signs are similar, so the energy will be decreases. So here we are having sigma 2 star, so it will go under the sigma 2. So here I am writing, that is minus plus, plus minus, that will be plus minus, here we are having minus plus. So both the energy will be here, that is decreasing, here that is increasing. So here we can see that the plus minus and minus plus, it will undercome other sigma 1 star, so it will go to the excited state. So I have to write down upward arrow, and here I am writing a downward arrow. The downward arrow will be in the sigma 1. In the notebook you can write down from the sigma 1 downward side. Here we can write down sigma 1 star upward side. So whatever the geometry is in the here we are having, we have to just copy down over here. Okay, so that will be minus plus, plus minus, minus plus and plus minus. So this is our correlation diagram. So after writing this correlation diagram, you have to just write down the conclusion. What will be the conclusion? So conclusion will, so now the conclusion will be, if your ground state electron will remain at the ground state, or excited state electron will remain at the excited state, or in other way you can say that BMO electron will remain at the BMO and ABMO electron will remain at the ABMO, at that time your reaction will be thermally allowed reaction. But if your BMO cross to the ABMO or ABMO cross to the BMO, then you can say that your reaction is photochemically allowed reaction. So in this we are having thermally allowed or photochemically allowed. So here we can say that the BMO electron will travel to the ABMO and ABMO electron will travel to the BMO. So we can say that this reaction, it is a photochemically allowed reaction and thermally forbidden reaction. Okay, so in the conclusion of this chart, you can write down from here that, okay, so you can write down like this conclusion from the above correlation diagram. We can say that BMO electron travels to the ABMO, thus it is thermally allowed reaction and photochemically forbidden reaction, or thermally forbidden reaction and photochemically allowed reaction. So in the conclusion, you can write down if BMO electron will remain at the BMO and ABMO electron will remain at the ABM. Okay, then you can say that thermally allowed reaction and photochemically forbidden reaction. But if you cross BMO to the ABMO or ABMO to the BMO, then you can say that it will be photochemically allowed reaction and thermally photochemically that will be photochemically allowed reaction and thermally forbidden reaction when you cross the BMO to the ABMO. So that will be our conclusion. So in examination they will ask a 2 plus 2 reaction, it is thermally allowed or photochemically allowed reaction. So here you can say that it is a photochemically allowed reaction and thermally forbidden reaction. Okay, so this is our 2 plus 2 cycloaddition reaction. Now let us understand that is correlation diagram for 4 plus 2 cycloaddition reaction. Okay, so let us start with the cycloaddition reaction, 4 plus 2 cycloaddition reaction. So I am writing one simple example, that is a 1,3-butadiene. When it combines to the ethylene molecule, what will happen? This will make a bond over here, this will travel over here, this will make a bond over here. So by the thermal or photochemical condition, in the end what will happen? Here we are getting a two new sigma bond, that is sigma 1 and sigma 2, and pi bond will be migrated. So here we can say that total there are 6 pi electron, 2 from here, 4 pi electron from here. So we can say that psi 1, psi 2, psi 3, psi 4, psi 5 and psi 6. There are total 6 wave function. 3 will remain at the BMO, 3 will remain at the ABMO. Second thing you have to find out the total nodes. The nodes will be n minus 1, so that will be 6 minus 1. So you can write down that the 5 nodes will be there. Okay, here you consider bonding molecular orbital and that will be the anti-bonding molecular orbital. After that, you just have to write down the correlation diagram, or you have to draw the correlation diagram for 4 plus 2 cycloaddition reaction. So how we can go from here? So let us draw this cycloaddition diagram for the 4 plus 2 cycloaddition reaction. Okay, so first of all you have to write down by this way, that is energy diagram. Then after you have to just see the BMO part as well as the ABMO part. Okay, then after what we have to do, we have to just write down 4 plus 2, that is 1, 2, 3 and 4. This will be 1 and 2. Okay, so by 6 way you can write down this thing. Okay, so I have written over here, that is a 4 plus 2. So after that, writing this thing, you have to just write down the nodes. So for the nodes we can write down from here, that will be the 4 pi. So it will be having 3 node from 0, 1, 2, 3, and it is having a 2 pi electrons, so it will have a 1 node. Then after what we have to see, here we can say that the pi electrons are remain as it is just migrated, but the thing is that two new sigma bond are formed, that is sigma 1 and sigma 2. So whatever the energy difference is there, it is just because of the sigma bond. There is no introduction of the pi bond. Why? Because the pi electron is only migrated from one place to another place. In this reaction, two new sigma bond are formed, so we have to just focus the sigma bond. So I have just draw this block diagram for the pi. Why? Because the pi electrons are not interfering this reaction, they are just migrated. Then after what I have to see, I have to write down the nodes. For these nodes, so there will be individually there will be the 4 pi electron, so it will have nodes is equal to n minus 1. So 4 minus 1, it will be 3 nodes. So I have to write down the 3 nodes from here. So it will have a 0 node here, that is 1 node here, 2 nodes here and 3 nodes here. I am not considering this pi star and pi orbital. Why? Because they are only migrated. So for this 0 node I have to write down minus, plus, minus, plus, minus, plus, minus, plus. Okay, then after 1 node, so what I have to write down, that will be minus, plus, minus, plus, sign will be difference, plus, minus, plus, minus. 2 node, so what I have to see over here, that will be 1 and 2, so it will be minus, plus, plus, minus, plus, minus, minus, plus. Then after 3 node, 1 2 and 3, okay, 1 2 and 3, so minus, plus, plus, minus, minus, plus, and plus, minus. Okay, in your notebook you can write down the whole page. Okay, I am not having that much of space over here, so I am congested over here, that is why I am writing. You just have to practice by this way. You have to write down particular this type of node, then after minus and plus. Okay, so now I have to write down, that will be my sine 1, sine 2, sine 3, it will be sine 4, sine 5, okay, and this will be sine 6. Okay, then after what we have to see, that will be the 2 pi electron. Okay, so in 2 pi electron there will be one node, so I have to write down minus, plus, minus, plus, that will be for the 0 node, so I have to write down 0 node over here. Then after it will not interact over here, so I have to put one node over here, that is minus, plus, and plus, minus. Then after, we are not having any possibility like 1 3 butadiene. So what I have to see, I have to just reverse this loop for the sigma 1 star. Again I am repeating, whatever I am writing over here is minus, plus, and minus, plus. Okay, I have to reverse this thing by the plus, minus, and plus, minus. Okay, so it will be plus, minus, and plus, minus. Then after one node over here, so what I have to write down, that is plus, minus, and minus, plus. Okay, now I have to see whether the energy will be increasing or decreasing. Okay, so now let us start from here. So here what we are having, so what starting with here, okay, then after I have to write down this thing, I have to just correct this thing. Okay, I will like to correct this thing. So it will be superficial, so it will have a plus, minus over here, not minus, plus. You have to write down plus, minus, and plus, minus. So if I put one node over here, so what I have to change, so that will be your plus, minus over here, it will be minus, plus over here. Now if I convert this thing to the excited state, it will be reversed from this place. So plus, minus will become as a minus, plus. So I have to write down minus, plus over here, minus, plus over here. Now again if I put a one node over here, so what I have to write down, minus, plus, so it will be plus, minus. Now let us understand by it's a thermally allowed or photochemical allowed reaction. So here we are having plus, plus, and plus, plus. So here we can say the energy will be decreasing. So in your notebook you can write down from the sigma 1 downward side. Here I am not having a space, so I am writing exactly from the sigma 1. In your notebook you can write down from the downward side. So here we can say that the pi electrons are remain as it is. Pi electron are remain as it is. There is two new sigma bond are formed, so we have to write down the sigma bond only. So here I am putting a pi bond as it is. Then after I have to write down whatever the terminal loop is there. I have to see this terminal loop from this side and from this side. Okay, so what I have to write down, whatever the sign is there, I have to write down over here. So that will be a perfect arrangement for my side. Okay, so here I can write down, that will be okay. So it will attach over here. Let us rub this thing. Okay, you just have to try to join this thing. Okay, then after whatever the sign is there, you can write down over here minus, plus, plus, minus, minus, plus, plus, minus. Okay, whatever the sign is there, you can write down over here. Now for the pi star or pi orbital, what you have to write down, you just write down by this way, that pi orbital is as it is. So you can write down from the below side, that is plus, minus, whatever the sign is there, you can write down from here, that will be minus, plus, so you can write down a minus, plus. Okay, so that will be your pi orbital. Whatever the sign is there, you can write down over here minus plus minus plus. Then after here we can see that the plus plus sign and minus minus sign, so the energy will be decreases. So now it will have a sigma 2, so it will not come under the pi orbital, it will come under the sigma 1. So what you have to write down, you have to write down by this the sigma 1, so it will come under the sigma 1, so it will have this type of property. So here we can write down by this way. So here we can say that sigma 1, that will be like this way. Okay, so whatever the sign is there, that will be minus plus plus minus minus plus and plus minus. This will from the downward side of the sigma 1, this is exactly from the sigma 1, that you have to remember. Then after here we can say the plus minus and plus minus, it will undercome at the sigma 1 star, so it will goes down to the sigma 1 star, sigma 2 star. So what will happen over here, so here we can write down the whatever the geometry is there. So here you can write down like this way. Okay, so by that way you can write down, that will be your minus plus and plus minus. Okay, minus plus and minus plus. Okay, then after the minus plus and minus plus. Okay, so this will energy will be increasing because of both the signs are different. Then after here we are having a sigma 2 star, so there will be sigma 2 star, both the signs are different, so it will come under the sigma 2 star, so the energy will be increasing over here. So what you have to write down from here, so here you can write down from here, so the energy will be increasing from this side. So here you can put down one picture over here. So what we can write down, that is your sigma 2 star, you can write down from the upper side of the sigma 2 star. I will send you the PDF of this side. So the explanation part I am explaining over here because of the PowerPoint I have taken over here, so I am not there is no much slide I can rotate, I cannot rotate the landscape to the portrait. So minus plus sign, so here we can put a minus plus sign. So here we are having a minus plus, here also we are having a plus minus, so that will be plus minus, so both the signs are different. You just have to see that this will come at the sigma 1 star, sigma 1, this will under the sigma 1, this will for the sigma 2 star, and this will above the sigma 2 star. Okay, so by that way you can write down. Here one more thing, the pi orbital will remain as it is, whatever the pi orbital are there, that will remain as it is, you can write down like this way. Okay, so here in this picture, in this correlation diagram, you can see that the BMO electron will remain at the BMO and ABMO electron will remain at the ABMO. So we can say that this reaction, it is a thermally allowed reaction and photochemically allowed reaction. So in the end, in conclusion, you can write down like this way, conclusion. Okay, what is your conclusion? So this is our conclusion. So we can say that from above correlation diagram, we can say that the BMO electrons and ABMO electrons remain at the BMO and ABMO respectively. Thus, it is a thermally allowed reaction and photochemically forbidden reaction. So this is our correlation diagram for 4 plus 2 as well as the 2 plus 2 cycloaddition reaction. So by that way you can write down the selection rule for this thing. So I am writing this selection rule. Okay, and what is selection rule? So if they are asking a long question of thermally allowed or photochemically allowed for the both the cases, like 4 plus 2 and 4 plus 2 and 2 plus 2 cycloaddition reaction, so you can write it down whatever the loops thermally allowed or photochemically allowed reaction. So here you can write down thermally allowed or photochemically forbidden, and second thing, that is thermally forbidden and photochemically allowed reaction. Here you can write down the 4n system and 4n plus 2 system. So here I can write down ms plus not ms plus na. You can directly go from here, that is sa and ss and whatever the geometry, that is s plus a, that is a plus s, s plus a plus s. Then after here we can have s plus s and a plus a. Then after here we can have S plus S and A plus A, 4n plus 2 system, that is S plus A and A plus S. Both are different from the, you can remember for the 4n system. In 4n system, here we can say that whatever the geometry are there, okay, so SS, BMO remain at the BMO, so we can say that it is a thermally allowed, photochemically forbidden, or SA or AS and AS. So whatever you are getting by your reaction, you can write down as a selection rule by your own. Okay, by your own you can write down the thermally allowed reaction or photochemically allowed reaction. Okay, so this is from my side for the cycloaddition reaction, correlation diagram and introduction of cycloaddition reaction. In next lecture we will see the FMO method or electrocyclic reaction. Thank you for watching it.